In order for the correct functioning of our model, we need a small and precise scale, and with this scale, just by touching it a little bit with an object, it gives us the weight that it measures. We will use a mass. In our mass we will be this object, which has anything inside of it. The measure of this object is 0.211 kilograms. This is an overview of our model. It is a model of a carousel which we always find in the parks. You may think that our model functions by spinning it around with this object, but not. We will not use it. We will spin it around by pushing the outer pieces. It can spin around with low speed, but our model is prepared for reaching high speeds. You can observe that the central object moves not in a straight line, but we will explain why. This is our central object. It seems to be straight, but it isn't. So you can think the radius isn't constant, but it actually is constant. It seems to not be constant because the central object isn't straight, but it is just decoration. It doesn't influence in the functioning of our model. We can compare it with a ruler in order to see that the central object isn't straight. In our model, we will use the scale not vertical, but horizontal. You can see that it isn't attached to the model, but we will fix it. We will use another part of wood, like this one, but perpendicular to this other piece of wood. And we will use adhesive in order to attach to the model. And that the compartment for battery is free. Without any object, we can appreciate that the scale gives us the centripetal force which we want to measure. We can observe that the centripetal force that the scale gives us is low. But when we add the object, we can see that the centripetal force increases. In order to see the centripetal force that the scale gives us, we will use a Bluetooth camera because when we spin around the model, we can't appreciate easily the centripetal force. So we will put the webcam here in order that the lens can focus in this part of the scale. One of the junior high problems is that students tend to be confused while learning scientific complex subjects like physics, and many studies done on children and teenagers state that while playing, learning is much easier, especially with real-life examples. This is why we have chosen a normal playground game named Carousel to explain something of the Newton's second law, the centripetal force. In this project, we explain the relation between velocity and centripetal force using this common playground game. Here we prove that the velocity to the square is proportional to the force. That means that the more velocity the object has, the more force will be applied to the object. The main physics topics that we manage in this project is centripetal force, but centripetal force comes from the second law of motion. This states that all resultant forces exerted on an object will produce acceleration in the same direction in which it is exerted. The magnitude of such acceleration is directly proportional to the magnitude of the exerted force and inversely proportional to the mass of the object. So the formula is F equals ma. By the other hand, centripetal force is the force that acts over an object in movement in a curved path, which is directed to the center of rotation. This force always acts perpendicularly to the movement direction of the body in which it is applied. Therefore, the formula derived from this is F equals mac, where ac means centripetal acceleration, which changes slightly with respect to the acceleration that we normally see. In the centripetal forces, the direction of the acceleration is always inwards along the radius vector of the circular motion. Also, the magnitude of the centripetal acceleration is related to the tangential speed and angular velocity, as follows. So if we combine both formulas, we obtain this one. But we will use the one that involves velocity. The formula of centripetal force comes from the following reasoning. What happens if the mass, velocity, radius is increased? The Fc will increase or decrease? In other words, this question asks which type of proportionality is present, and it was deducted that mass and velocity were directly proportional and radius was inversely proportional. But velocity needed to be squared so that the proportional conditions could fulfill. Below is explanation why velocity needs to be squared.